Yo, what's up, everybody? Welcome back. Today, we are working on writing a GLTF exporter for our code visualizer. Because we have been working on this thing. Let's quickly show it. Wrong window. Uh, Maybe we show it here. Close. Don't save. Okay. Zig, build. Okay, this is our code visualizer. He runs abysmally slow right now, and I have some performance fixes that we need to do. But in order to do those performance fixes, I think it would be easier to visualize these things if we visualize what is happening here in 3D. But just to give like a little quick background, each of these backgrounded sections are basically saying for each pixel, which node in this graph am I closest to, and let me color it appropriately. This is done by basically instantiating a cone at each point in this diagram, right? So if we were to close this and we were to imagine we have a point on the graph, we are looking at these points from up above, we are looking down, and we are looking down into cones that we've generated. What happens is if we just say this cone is like yellow, right? This is a yellow cone. If we take a blue cone over here and we drop it like here, this cone is blue, you're going to see from your perspective up top, blue, 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 yellow, 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 right? That's kind of what we're drawing. And so we're also kind of drawing this, you could imagine, in like many layers, right? We have like kind of like one layer here, one layer here, one layer here, and you're kind of looking through like all of them, and as you go down the layers, the cones get fatter and fatter. Yeah, this is really slow. Anyways, I have some ideas on how to fix our performance issues here. If we like look at, I guess I should show like how bad it is. If we look in RenderDoc, which I finally got working, it turns out I can't get it to work in Wayland. But if we capture a frame here and we go look at the diagnostic data that comes out of it, I go here, I hit this little time button that says, hey, RenderDoc, could you please calculate how long it takes to draw this thing? He says, your frame is taking 30 milliseconds to draw. Bro, what? 30 milliseconds? That's so much time. And he's like, okay, your first draw call is drawing this version of the map. As we kind of like draw more and more, this map gets like more and more detailed. So we kind of like go layer by layer, which is stupid in its own way. But this is saying your first thing, drawing 1,020 triangle cones, is taking 16 milliseconds. That's so many milliseconds. Dude, I can run like full games that are doing like complex lighting with like hundreds of thousands of vertices at like 144 FPS. Like, what's going on here? What is happening? Anyway, so that's what we want to look at. I have some ideas on how to fix that. But before we do that, I think it'd be more fun to visualize this scene in 3D, because visualizing this scene in 3D will allow us to kind of make sure that as we apply fixes to this thing, that it's like geometrically correct. And so I was looking like 2 minutes ago at how to export this stuff to Blender. And I was like, okay, we've looked at like obj files before, and I like Googled some stuff about obj files. It didn't really come up with anything useful. So I was like, okay, fine. We'll fucking ask like the fucking AI. Oops, wrong thing. Fuck, what did I just click? That's annoying. We'll fucking ask the AI. So I guess I went here, and I was like, in obj files, is there a way to specify many instances, right? Because what's happening when we're drawing is we're drawing one cone, and we're drawing it in like a fuck ton of places. And he's like, no. But you could use a GLTF. And I'm like, okay. What's in a GLTF? GLTF sound kind of fun. That seems like, I've heard of those. Those are like scene exports for 3D geometry, right? So we open up Blender, and we're like, what the fuck is in one of these GLTF files? And so I like, we start our like sample scene. We like duplicate this cube in a way where it's referencing the same geometry, right? This is kind of doing exactly what we wanted to do for our visualizer. And if we say, yo, can we export this thing as a GLTF? It says there's like a binary format and also like a non-binary format. If we just slap this export button and start looking at what it spits out, we started something like very interesting that made me realize that this is worth its own stream. I was going to do this in happy hour, but as soon as we started looking at the content of this thing, we're like, holy shit, wait, this thing seems sick. So let's just say all I know about GLTF is that JSON blob, binary format as well sometimes, and can export like full scenes with like certain material properties. I don't really know much more about it than that. So we just open this up and we're trying to guess like, so we know we exported 2 cubes. What are we looking at here? Okay, so if we look at like this like nodes section, we find like cube, cube. Okay, so this is probably like our two instances, right? That are both referencing the same mesh. We see mesh 0 in both of these, right? And so we kind of keep scrolling in here and we see, okay, meshes, okay, meshes. So meshes is, he has a primitive and these are like attributes. But like, where's the mesh data? The mesh data is like totally fucking missing. What's going on there? Okay, indices 3. I wonder if that's useful in some way. Like, or maybe somebody else ties the mesh data back. And we kind of like skimmed down a little bit more and we were like, okay, well, first we were looking for maybe it exports like a sibling file, right? So we look at like a time-stamped file list and we go, oh, wait a second. There's a binary data next to this thing. And we tried like looking at that thing. It didn't look too like obvious what that was. Right? I don't know if this thing doesn't like really look super interesting to me. I don't see any like obvious. I don't see like any strings in here, right? It's just kind of binary blob. But you kind of notice that this thing has like the GLTF file has like a buffer section that says there is this thing called untitled bin, and very interestingly, there's this thing called buffer views. Okay, so in buffer view here, we're like, okay, let's look at like the the first 288 bytes, and I guess it has like another section of 288 bytes, and then some sections of this stuff. Who knows, right? But in here, this is where I looked at this, and we're like, oh shit, this is actually kind of fucking interesting. Right, so this is like, this thing is defined as an accessor. And he's like, let me look at the buffer view 0, which comes from buffer. So our binary data, the first 288 bytes, are being referenced by this thing. And he says, this is like some component type. There are 24 things in here, okay, with these things, and these are vec3s. So there are 24 vec3s in this thing. Okay, so this is probably our fucking mesh data. This is our mesh data. And so I saw this and I'm like, that's cool. That's cool. And if we are going to export something like this, we can probably figure out this format just by like poking and prodding. So the plan of action is to just try to like try to understand what we're looking at here at all. Then we can try to export like the world's simplest GLTF with just like a single mesh or something. See if we can get it to like show up in Blender. Then we can like try instancing it. Then we can try adding materials. But I thought this would be kind of fun to play around with. So that's the plan. That's the plan. Hello, man. Hello. Hey, I like your YouTube vids. Awesome content. What's your background? CS degree? Currently student, senior dev. I've like worked for a little bit. I like did like computer engineering, and then I've like worked for maybe 8-10 years or something. And, like a lot of C++ type shit, camera firmware, some like neural network stuff. Nothing too crazy. And then we do this because it's fun. Okay, let's try doing something. So we could look up docs. That's probably a good call in here. Can we look up like GLTF spec? Is that like a thing we can find? Working on the image editor as usual, I see. Yeah. We're kind of, yeah. Okay. GLTF spec 2.0. Spec as HTML. Okay. And can we just like GLTF basics? So we have binary files, image files, JSON. Okay. Here are some things with nodes. Okay. I don't really care that much about that. Oh, here we go. Okay. Scene, references node, references mesh, references accessor, references buffer view, references buffer. Okay, that's what we found so far. So this is good so far. That lines up with our initial guess. Can we look at what the fuck is in a mesh? The piece that I'm missing here is how does this link to this? I guess probably the position attributes are probably stored in accessor 0. Normals are probably stored in accessor 1. And texture coordinates are probably stored in accessor 2. And the index buffer is stored in 3. That lines up here with this thing being a scalar, this being vec2, vec3, vec3, right? Vec3, vec3, vec2, scalar. Okay. Okay, yeah. And then I guess the missing piece here is probably how vec3s are stored. But we could probably guess this by just interpreting the first 288 bytes of this thing as packed floating point data. That would probably tell us the vertices of our cube. Okay, let's undistort this cube. Let's go back to like a proper cube with vertices at like expected locations. And can we re-export this thing now? And let's just look at the first whatever 24 floats, I think is what they said, right? I think it said something like that. Okay, export. So can we let's get into a Zig repo and just start playing around. I guess probably working in our code map repo makes sense because we are eventually going to be putting the exporter here. And let's just take a peek skis. I guess we should change the title of our stream, huh? Oops, I wrote some bad OpenGL to writing a GLTF exporter. Okay. So I guess we make a GLTF export or GLTF test Zig, I guess is probably a fine place to put this for now. And let's quickly just say I want to make an executable called GLTF test. Okay, and this we have to install artifact with the test, GLTF test, okay. So hopefully now we see something. He's pissed off because this thing needs B and check step, okay. True. Give him a sec. And GLTF test has no function named main. Okay, that's a good point. Pub function main returns void, and we return error. Hello world. Just to see something happen. Hello world, baby, let's go. Okay, so let's open import std. Let's open that file. Open file absolute, which is home streamer untitled bin, I think was what it was called. So we have this file, and can we get a reader out of this thing? And can we do like reader read? Can we like read this thing directly as floats? Read int? No. Okay. Can we read all, I guess, into, can we read this into like a pointer cast of a float or something? I wonder if this is allowed. Or std mem as bytes. Yes. Yes. So we say f, or for like some like, you know, we would assume this is like vert. I guess we'll call this. So we know vert is this, and we say for 0 to 24, which is how many we expect there to be, we get this like 32-bit float, which we're assuming. We don't actually know if it's 32-bit yet. That's just my guess. I guess we could probably take a guess. We could figure this out, right? So they said it was 288 bytes over 24 elements. 12 bytes per element, but it was a vec3, so 4 bytes per thing. So for 0 to 24, for 0 to 3, we read a floating point thing and print it, I guess. Okay. So this is our vert. We new line after each vertex. And I guess we see what happens. I guess it's like this. Okay. Zig build. And zig out. Bin. GLTF test. Oh, come the fuck on, dude! That's a cube! Look, we have... Wait, okay, so why are these things coming out 3 times each? 1, 1, -1, 1, 1, -1, 1, 1, -1. Why are each of these tripled? Huh. Interesting. Okay, can we try like moving one vertex around and seeing what happens then? Okay, so we get that one vertex tripled up over here. Have you tried ghosting instead of alacrity yet? Not yet. I don't know if I will. We'll see. Do I have a bug in here? Like, we have how many rows here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21, 22, 23. Yeah, so that's 24 elements, which does line up with what we saw in the GLTF. And so, is it because we have 3 triangles connected to each vertex? Maybe. It could be. Right, it could be that this thing, if you were to like triangulate this and show like let's see. Where is the like triangulate button? Mesh? Face. Triangulate faces. Each this is 1, 2, 3, 4 triangles connected to this one vertex. So maybe not. Maybe it's there are 3 quads connected to this vertex. 1, 2, 3. I guess if we look at the index buffer, this will make more sense. As for is the GLTF form popular? I think it's made by the same people from OpenGL. I don't know. I'm not really like much of like a. I'm not really like in this space very much. But my understanding from like the little bit of like game programming I've done is that like creating your models in Blender and exporting them as GLTFs to import into like Godot or Unity or something is pretty common. That's my understanding, but it might just be that like that's like the thing that happened that I came across when I googled. Okay. Um should we just try like making something? I think that we've like interpreted this data. I guess let's look at the index buffer. Let's look at the index buffer. So the index buffer is buffer 3. So we need to look at byte offset 798. And we need to look at 72 bytes. Oh wait, sorry. Index 3 is accessor 0, 1, 2, 3, which is buffer view 3. Component type. What is component type in here? Is that in the spec somewhere? Those are just numbers. Okay. Sick. Okay. Okay, cool. So here we have component type 5126 float. Is that what this is? This is 5123. So 5123, we're expecting unsigned shorts in this segment. What key we're using? It's a Durgod K320, but I don't think it really matters. I just have like a 60% keyboard with brown switches because I like the feel. But in reality, those are just the only ones I've tried. It's like, I don't know. At work, I would just use like whatever shitty keyboard they left there, and it doesn't really make a difference. They're all the same. I care way more for gaming than I do for typing. Okay, so we want to look at the index buffer here, right? Indices 3. And I expect what we will see is these like duplicated vertices will be referenced by the index buffer in some way. That's my guess. Okay, so we're looking at this thing is buffer view 3, which is this one, byte offset 768, byte length 72. Okay. Can we leave this open maybe and go back to our GLTF test and let's say reader seek f seek to seek from end relative to the beginning. Okay, so seek to. We will seek to the byte offset of 768. Okay, and then we will say for 0 to 36, we are going to read single unsigned short. Okay. Okay. And let's see what that does. Fuck. Oops. New line has to go outside here. No commas. Let's get those out of the way. Okay, so we get 2, 13, 18. 2, 18, 17. So someone's referencing vertex 2. Some people are definitely looking at vertex 1 as well. And some looking at vertex 0. Okay, so 2, 13, 18. Maybe we should specify the index of the vertex as well. Let's do that. That'll make it easier for us to like identify which is which. Okay, so we're looking at 2, 1, 1, negative 1, 13, negative 1, 1, negative 1, and 18. Negative 1, 1, 1. Okay. And then 2, 18, and 7 is just we swap this 13, negative 1, 1, negative 1 for 7, which is this. Okay. I still don't fully understand why they're duplicated like this, but it does seem like they are all used. Okay. I bet we have enough info to make the world's shittiest GLTF. I'd be interested to try to export something that Blender can consume. So let's make a GLTF. And we know that this thing has okay, well, first of all, let's see like what's mandatory. How do we know if it's mandatory? Like, is asset field mandatory? JSON schema. Okay, asset properties. Okay, so he has properties in here. And are all of these like does it define if they're optional or not? Required asset. Okay. So asset is the only required thing and everything else is optional according to this schema. Sure. So let's start, I guess, with literally just writing asset is a I mean, we can probably make a guess based off this, right? He's saying you need all of the things in that schema, right? And we can probably guess what those things are from this, right? So this has a generator, which is a const u8, and a version, which is also const u8. So let's just export this thing and see if it is importable by Blender. Okay. So can we write stream? How do you like fucking stringify into some writer? Okay. So we'll say gl like out is going to be, you know, some current working directory relative file on like test GLTF. Okay. We stringify our value. So we'll say our GLTF is going to be a GLTF that has asset equal to version, probably 2.0, we probably want, and generator is equal to like smile. It's us. Hello, smile. And let's stringify this shit. So we take this GLTF and we probably want like at the very least white space so that we can read this thing when it comes out. Okay. And then we say out.writer, question mark. Seems reasonable to me. Seems reasonable to me. So this thing has our data in it, and let's try to import that thing and now see what happens. Okay. So we go work, code map, test GLTF. No errors anywhere, I think. Let's try like deleting. Let's say we don't include this stuff, right? I'm assuming that we'll see some form of like failure from Blender's side. Yeah, bad GLTF, no version in the bottom right. So we put that stuff back in, and he looks like he's probably happy. Right, we go yoinkies, yoinkies, no errors down here. So I think we're chilling. Okay, what now? Let's try to can we like make a scene? Let's try shoving a scene in there. So we're gonna have what does like the top level scene directive do? Concepts, scenes. May contain 0 more scenes. Scenes are defined by a scenes array. All nodes listed in scene nodes array must be root nodes. They must not be listed as node children of any node. The same root node may appear in multiple scenes. Okay. What if we don't have a scene, though? Maybe we just try slapping some nodes in here first and just see if that gives us something like visible in Blender. So this is an array of this, where each thing is going to have, for now, a name, and that's it. Okay, let's just do this for now. That's crazy that you can define stuff like this, by the way. That's weird. Okay. So nodes, and I guess, is this thing optional, technically? Right? It's kind of optional. Okay, so that still works. Okay, so now we start adding in some nodes. So we go like name equals hi. And we'll do another one. Mom. Hi, Mom. Okay. And what's he pissed about? Expected type slice found question mark slice found this thing instead. So I guess this doesn't autocast, which is a little annoying. But if I take the question mark away, then does it fix itself? Oh, wait, if I write const, maybe it's fine. Ah, wait, put the question mark back. Aha, there we go. Okay. Zig build. Okay, so we have hi mom there now, and if we go back and import this thing again, I want to know if we can like find that hi. Come the fuck on. Come the fuck on. We have some empties, hi and mom, and they just kind of work their way in. Okay, so we don't need a scene, it looks like. It looks like if we have no scene, it will automatically just import them at the root. That's pretty cool. Pretty cool. Okay. So now we just need to like inject some data with these things. So we know that these things are going to have like a mesh field, right? Okay, if we have, first of all, let's look at the nodes section here. Asset, coordinate system, nodes, hierarchy. Okay. So do they say, where does it say like the fields? Mesh. Okay, so this here. Joint hierarchy, nodes. A mesh is instantiated with a node.mesh property. So this is in 374. So this is in geometry mesh, geometry instantiation. Okay. So we can assume though that we'll just kind of we'll go by vibes instead of by spec. Fuck spec, am I right? Okay. So this is going to take in something that has name. I guess technically this is probably optional as well. I guess we should check. Meshes. Okay, the following meshes are defined as arrays of primitives. Primitives correspond to the data required for GPU draw calls. Primitives must specify one or more attributes corresponding to the vertex attributes used in the draw calls. Index primitives can also define an indices property. Blah blah blah. Okay, I just want to know, like, where the fuck do you talk about its name? Hello? Is name required? Not required? Where is like the mesh name? Overview. Any node may contain one mesh. Its mesh property may be skinned, may have morph types. Wait, what about like name? Vibe, VDD, vibe driven development, immediately looks back at spec. Okay, well, okay. I mean, chill. I mean, I didn't want to. Where do they talk about like names? I guess we should just assume that everything can have a name. Does it need a name? What if we just don't put a name on one of these? Like, can we just like delete the mom one? Meshes has to be by default be null as well. And we just import again. And does he yell at us in some way, shape, or form? No, he just gets his own default name, node1. Okay, cool. Cool, so I guess we don't have to name our meshes if we don't want to. We could, but we don't have to. Well, we don't have to name our nodes. We're going to assume the same about meshes for now. Okay, so we know that our mesh is going to have some primitives. I wonder if these are required. Meshes. But meshes are defined as arrays of primitives. Primitives correspond to the data for GPU draw calls, blah, 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 blah. It looks like probably required, right? And each of these is like some structure as well. And the structure is attributes, which I guess is like how do we like define this? Probably just like a hash map, right? I don't really know, or is this like yeah? How does our like stood JSON here do like key value stuff? Zig JSON key value. Um. Bump 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 bump. Guide? Guide? Okay. We'll follow the dumb stupid people way. This is not helpful actually in any way, shape, or form. This is like the most useless link of all time. Okay, what about like if we just go into the zig standard lib? Does this guy have a way of like exporting like hash maps? Object map? Okay. Sure. Sure. That seems kind of sick. We'll use that. So this is a top level, I guess, array of stood JSON object maps. Yes. But I guess we have like kind of like a known constraint here. So we can use like stood string hash map into usize question mark. What does it say the values of these things are? I guess it's just JSON numbers, so sure. Okay, so if we want to make a mesh that just has positions, we don't care about texture coordinates, we don't care about normals, we might not care about indices. Let's just try to make a single triangle. Okay, we'll make a single triangle. So we're just going to have a mesh which has You know what we could do here, actually? We could do, like, GLTF mesh primitive is a structure that just has the things that we know it can support. Right? Right? Like, we're seeing all of these things. So I guess we can just kind of hard code them in here like this. Which means that that should make it easy for us to go like meshes equals like this. We have some name equals mesh. We have some primitives equals this thing. Slice, I guess. I think we forgot a const somewhere again. Expected this, found that, so I guess this comes like in another pair of braces like this, and then our primitives, we need like position equals 0. Okay. Okay. That compiles, maybe? Nice. Okay. And then probably looks sane. I'm not really too worried about it. We now need to define that thing. So I think that thing is an accessor, as far as I can tell. So this is going to be, an array of structures defaulted to null. And I wonder if we need these min and max in here. I would assume that's optional because this guy doesn't have it. We know that we have our component type 5216. So we're going to say here, component type. Can we do like float equals 5216? Is that the thing we can do in this language? And then like, I don't know, U32 or something. Sure. So we know that float was 5126, which we got wrong here. And then we know that unsigned short is 5123. Okay. And then how do we specify that in here? So accessors, we know that we have a buffer view. Which buffer view we're referencing? We know that we have component type, which we'll just say is a U32 for now. It would be nice. Yeah, it's fine for now. Count looks kind of required. And type is, I guess, a string. Although I assume that this type can be one of like a few minor options, but for now we'll just write it as the string for now. And I guess here, can we say like function 2u32 for now? I'm sure there's a better way to do this, but I don't really want to think too hard about it. Float goes to, I guess no matter what, we just return like in from self. Yeah. Okay. So now we have some accessors. And our accessors, we have like buffer view is 0. Component type is going to be GLTF component type float to U32. Okay. We have count. We're going to have 3 for one triangle. And our type is going to be vec3 for now. I'd be interested to know, like, where these come from. Here we go. So we could do this. GLTF like, what is it? Accessor type, I guess? These are our allowed options. Okay, and we kind of do this. Okay. And then here we can go like GLTF accessor type dot vec3 and then do like tag name here. That way at least like we have like a list of things that will autocomplete for us. Okay. So now we have to construct our buffer views, which must have this format. It must. I don't know what target is here. I do not know what target is here yet. But I'm sure we will find out. Oops. This stuff. Okay, so what we got? What we got in here? Buffer makes sense. So buffer is which buffer it comes from. Byte length, probably U size is fine. Byte offset, probably fine. And like target, we need to figure out what the fuck that is. So this is in buffer views. You think it's a morph target? That seems kind of likely. Buffer view target integer. Use integer enums defined in the properties reference here. Ah, no, it's one of these. Sure. So this is telling us if it's like data or index data. So we'll say that the target is a U32 for now, and then we'll define buffer target as an enum backed by U32 in the same way we did before. We have array and element, and we'll do the same like 2U32 thing here. Different target smile? Yeah, I guess so. Okay, so buffer views also should probably be optional by default. And is target required? Where is this like buffer view stuff defined? 5.11. Okay. It's a hint. I see. Oh, here we go. Required, yes, for buffer. Byte offset, not required. Byte length, required. Byte stride, not required. Target required, no. Oh, okay, nice. Nice. Okay. I think we're just not gonna define this, right? Just fuck it. We don't need it, so we won't. Like, who gives a fuck? Okay. So let's do buffer equals 0. I already forgot. It's buffer, byte length, and byte offset. So if we're going to do one triangle, byte length is 12, and the byte offset is 0. And I guess byte offset technically is optional. Because it might be, like, it picks 0 by default, I think is what we saw in the spec that we just read. Which we aren't really reading, but you know, I think we saw something like that in there. And then the last thing is our buffers. So we should be able to be like, buffers has elements of URI, which that doesn't look like a URI to me, but whatever. Okay. So here we say, let's add in buffers that have something like, what was it? Byte length and URI. So we'll call this a test GLTF bin. And we'll say byte length is also 12, I guess. And now we need to create that file. So we'll say we have some out bin, right? And in here, what is this? Test GLTF bin, like this. Okay. And what are we doing with this shit? We're gonna throw some vertices in here. So let's just put a triangle that starts at like 0, like, I don't know. We'll just have to write 3 floats. So we'll do something like this. And he's like got like, I don't know. Wait. He needs 3 vec3s, which means that there needs to be 9 floats, which means that this 12 needs to be 36. And this buffer view needs to be 36 bytes. And that will make it so that we can have 3 vec3s. Yes. Okay. So 1.0, 1.0. Let's just say, I think Z is up in Blender, so let's fix. Is Z up or Y up? Let's look. Z up. So let's fix Y. And we'll kind of make our triangle like this. So we have positive here, and then centered in X and up in Z. Okay. And then can we just go like out bin right all like stood mem as bytes triangle question mark? I feel like that should work. He's mad because we probably have to put like a ampersand on this. Okay. Can we like hex dump test GLTF dot bin? Hello? Maybe we have to run our code? So this has 1, 2, 3, 4, 5, 6, 7, 8, 9 floats. Seems good to me. Seems good. And so that's like a very maybe like this thing will import. Right? It's like not a no. Check that the file is valid. Fuck. Fuck. Well, that's cool. That's super cool. So which of these like things do we, I guess we just start commenting shit out. So I guess we start at the lowest level, add what we can at the lowest level, and then work our way up. Import GLTF. So that's fine. We add in buffer views now. Let's see if he likes that. Okay. Boom, he's fine with that. So what if we add in our accessors now? Okay, he's fine with that. So it must be something to do with our meshes, question mark? Import. Yeah, okay. So first of all, let's like actually look at this thing. Oh. We need to omit null fields. We should have just looked at the data. That would have given us a frickin' good clue, dude. Still no? Okay. So now we have primitives. Does this match what we saw? Does this match what we saw? Primitives. Test GLTF. So you have meshes, open brace, squiggle, name. Okay, chill so far. Primitives, same thing. Oh, we forgot attributes of material. Ah, right. We saw something about like them requiring a default material, right? I think we saw something about that. But at the very least, our position field here is wrong. It's supposed to be attributes here. Okay. So here it's construct here. Attributes is this thing, I think. Yes. Okay. And so now primitives needs to be attributes equal to this. Okay. Let's see how if he is okay with that guy. Import GLTF, please. Okay. Ooh, he likes that. Okay, so now can we attach the mesh data? Can we attach the mesh data to the node? Hey, how's it going? Hey, Clonky, what's up, my boy? What is up? It's going okay. We're kind of just like guessing almost. We have the spec open, but we're like more going off like an exported cube from Blender. Trying to figure out if we can like make a mesh, slap it somewhere, and instantiate it like 1,000 times. That's what we're trying to do. Okay, so we have this thing. Let's attach this thing to our name hi. So how do they do that? They have nodes mesh 0. So here we should be able to be like mesh equals 0 here. And then our nodes needs a mesh field. Like this, I guess. Did I do something I didn't want to by mistake? No, we're chilling. Okay, and then zig build, run this thing. And let's clear our full scene. I'm tired of seeing all this shit. And can we import our GLTF and see if we get a triangle? Oh, come the fuck on, man. Okay, so axes are not what we thought, right? We tried to, it looks like the GLTF probably specifies Y up or something. And we were using Z up because we were trying to just match what Blender does. But I guess Blender probably does some like axis swapping in there. But that's pretty fucking sick, dude. That's a fucking triangle, dude. Hell yeah. Okay, so now can we do like mesh instancing? That'd be kind of cool. Do we want to change this thing to a cube? And do we want to like improve the like exporter now? It might make sense for us to try to do something that's like export GLTF, and maybe we take a mesh. We take a mesh, which is going to be a bunch of like floating point things. How does like OpenGL index buffer work? I'm pretty sure that we still want to take in vec3s. I think. Wait, is it this way? 3 F32s, not the other way around. So we're taking a mesh full of vec3s, and we take in... I guess that's kind of it for now, right? And probably like a writer. And surely like all of this code just ends up in here somewhere. So here we will say that we have like bin writer, like JSON writer, GLTF writer, and bin writer. Okay. So then we don't have to do this stuff. We just say like, we take the mesh and we export it as bytes to the bin writer, right? Okay. Then this gets the GLTF writer here. And now we just have to make sure that the parameters of this thing match. Okay, so we have one mesh here. He has one position buffer. We assume that he's using, yep, floating point vectors. And here we just have to do mesh len here. Here we do mesh len times size of vec3, I guess. And here we probably do the same shit. Okay. Yep. Okay, and then we actually lost some of our code there, which was stupid, but that's fine. We'll just rewrite it. So we say now, the GLTF file is current working directory, create file of test GLTF. Okay, and then we have the bin file is we said test gltf.bin, which means that like the names of these things have to come in. So maybe we actually pass the paths here instead. I guess the test GLTF doesn't show up anywhere in here, but the bin path does. So the bin writer comes in as a path, but the GLTF writer comes in as a writer. Sure. Okay, so we need a bin writer is equal to try std fs current. I guess even then, you kind of need to know that this thing is like a sibling to the GLTF writer path. So I guess we'll take them both in like this. I think that's fine. We want cones eventually, right? Yeah, eventually. Eventually. Okay, so that's our bin writer. And then we have the GLTF writer here. Okay. Sure. Seems reasonable so far. So now we just say export GLTF with some mesh and test GLTF and test GLTF bin. Boom. And now we write try here and we put our triangle again, which we had at like, you know, something like this. This was negative, this was negative, this is positive, this was 0. Yeah, something like this. And then I guess now we kind of want this like this, where each one of these is its own vec3, which I think is fine. That matches up with what we have on the other side and like in our cone stuff, so seems kind of reasonable. He's mad because root struct file has no member named error. Because here we actually want, this is GLTF file, and then we want the GLTF file writer here, not just the file itself. All right, and if we re-import this thing, we're expecting to see now a triangle that's rotated so that it's vertical. He's pissed because buffer is smaller than requested size. Interesting. That's interesting. So hex dump test GLTF bin. Yeah, that does look small, huh? So because we took the pointer here instead of the value, we took the pointer to the pointer. Oops. Still no good. Slice as bytes. There we go. Because this thing's a slice now. That's looking a little better. Although this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bytes. Feels too long, which makes me concerned that this vec3 is padding itself in a way that it shouldn't. Each vector 3 might be padding itself out to like 4 bytes instead, or 4. No, that doesn't make sense. I don't think. It wouldn't be padding itself out to be like U64s, right? I don't think that makes sense, but I mean, we're also kind of seeing that, so. Maybe this is no good. Maybe we have to take this thing in as a bunch of floats. which is fine. We'll just see if this behaves any better differently. Okay, so we look at this again. Now that's the right size. And if we re-import in Blender now, does it look okay? Buffer is smaller than the requested size. Okay. What have we done wrong? Byte length 36. Test GLTF bin. Oops. Can we do dash B? 36 bytes? Okay, so that's right. 36, 36. Oh, this thinks there's 9 vec3s. That's why. That's why, because we refactored. Where the fuck are we? How are we in this file? Test GLTF. GLTF test, I'd say. There we go. So that means that this blend thing has to be over 3. Oopsies. Oopsies, oopsies, oopsies. Alright, let's try again. Import GLTF. Womp womp. There we go. There's our triangle, baby. Okay, so we'll say that this was actually kind of a side quest to, factor out function. Now we're going to work on instancing the mesh. Okay. So if we want to instance this mesh, we're now just going to take in a bunch of like instance transforms, question mark? Do we still have this guy open? So when we had 2 cubes exported, there was a translation field on the node. Okay. Okay, sure. So that means we need to add an optional translation field here. All right. And what goes in here? It's actually, was it a 3-dimensional array? Okay, so like this. And I guess we define the nodes here in some way. So I guess that means that this thing has to actually kind of get its own name. That's going to make this easier to work with. Okay, and here we're just going to say GLTF node. I think in reality, what we would probably want to do is we would probably want to like export this thing piece by piece instead of like forcing ourselves to generate a slice here, right? If you don't want to have to allocate a list of nodes, then it makes more sense to be able to say like JSON writer dot write node type shit, right? But we're not going to do that right now because I'm a lazy piece of shit. And instead we're going to do the stupid thing, take an allocator. Okay. We are going to allocate a list of nodes that matches the like instances here. So this is going to take in a bunch of vec3, I guess. Vector, what was it, 3 after 2, or was it the other way around? Yes, this way. Okay. So it's going to take in a bunch of vec3s. And what we're going to do is we're going to just like literally just go like alloc. Did I spell allocator wrong? Oh, this needs to be a semicolon. We're going to say allocate this many GLTF nodes matching the number of instances. Okay. And then down here, we are going to write nodes is equal to nodes. Boom. Okay. Now all I have to do is initialize this thing. So for 0 to instances len, or maybe we can go for instances nodes, and we can get like an instance and a node. Then we could like copy this thing in, except the nodes needs like a name, but the name is optional, right? It's actually optional. So, sorry, here. So in each of these nodes, we're going to say mesh is equal to 0. We only have one mesh. And the translation is going to come from instance like this, question mark? I wonder if this coerces that way. Export GLTF is mad because now we need our allocator and our instances. So we're going to just start with one instance at 0, 0, 0. Maybe we'll start with 2 instances actually. One at 0, 0, 0, one at maybe this is gonna be like vec3, 1, 1, 1 or something. Let's just kind of see how this plays out. We need an allocator, so we pull the general purpose allocator out and his generic interface, his runtime interface. So GPA is stood heap general purpose allocator with I don't give a fuck arguments. And we deinit this thing later, and then probably we have to deinit our nodes here, right? Alloc free nodes. Wow, wow, wow. Okay. So that compiles and it runs. And if we delete this and import him, do we get 2 triangles? Oh, that's so sick! Let's fucking go, dude! That's so awesome! Okay, so now we just have to be able to like color this thing in. Okay, so let's let's add a material to this thing. Let's add a material. So fire, hi. Let's add some color. So how do we fucking do that? I guess we just look. So they had materials defined at the top level, and they reference the materials from where? Meshes? Yeah, the meshes are tied to each mesh ties to a material. And then the objects are tied to individual meshes. Okay, cool. So what I want to know is, can we override the material on a per object basis, right? When we're going to be drawing cones, we want to use the same cone everywhere, but color the cone differently depending on where it lives. So it would be nice if we could attach the material to the node instead of to the mesh. That would be pretty fucking sick. So can we look at like nodes? Where does it define like the type of shit that we can put on nodes? Like, or materials here? Okay, materials. GLTF defines some materials, blah, blah, blah. How do we like link these things to other guys? Doesn't really say here. But we can look for usage of material in as a property. Okay. Okay, so if we look up like, let's ask a AI. In GLTF, can I attach a material to a node instead of a mesh, question mark? So he's just put material in nodes. Do you think he's a lying piece of shit? Or do you think he's telling the truth? Node schema JSON. Okay, so in the node schema, there is mesh, rotation, scale, translation, weights, matrix, skin, children. So he's just like a lying piece of shit, right? He's just a liar. Can we look up this? Is there like overrides for this? What if I just tell him, you are a lying piece of shit. Okay, let's we'll be a little nicer. GLTF schema indicates we can only put materials in the mesh. AI abuse. You're right. My previous statement was wrong. Shut up. Fuck these. Okay, it's fine. So, but I guess if we create many meshes, I wonder if they like reference the same data. I wonder. So can we try? So, fuck. Maybe like somebody on Google will have an answer for me. Instance GLTF mesh with different materials. Export single mesh. I mean, actually, let's just fucking do this in Blender and see what it does, right? We can just do that. So can we like make like, uh-oh. Are we alive? What is, okay, so my desktop isn't crashing. That's good, but Blender seems to be, oh, there we go. He figured it out eventually. I don't know what the fuck that was. Okay, can we create a new material on one of them? So this is gonna have material 0. This has material also 0. What if we click this button? This button says, let me distinguish them between these guys, I think. No? Yeah, how do I fucking... There's a button somewhere. Oh, this button. Attach the material to the object, please, instead. So this is material 3, this is material 1. Now these guys should still, under the hood, be using the same mesh. Good, okay. And so can we just, like, make some visible changes to these materials in some way? Oh, is that button gonna, like, fuck up my Blender? No, okay, what about this button? Let's do this. Shader editor. Can we just make one of them, like, fucking, like, red and one of them, like, blue? Okay. So if we, like, export this scene now, what does Blender do here? Okay. So here we have material 1, material 3. One of these should look red as fuck. This one. One of them should look blue as fuck. This one. Okay. Now, how are these guys used? So they use the same buffers here, but they have different materials attached to them. It looks like. Hi, so how many levels deep are we in the tangent hole now? Well, we're running a GLTF exporter so that we can visualize our Voronoi diagram generation, so that we can debug performance issues in our Voronoi diagram generation, so that we can add backgrounds to a star map visualizing our code base, so that we can continue working on our image editor without people getting lost. So 5? We're getting a little far. We're a little far. This is my first time watching what's going on. We're running a GLTF exporter. We're trying to take some 3D meshes and spit them out in a way that Blender can render them for us, because I thought this would be easier than writing a 3D renderer for our thing. Now I'm kind of like 50-50, but it's kind of fun either way, so whatever. LG, thanks for the sub. Much appreciated. Okay, so I'm curious now if we re-import into Blender here. What does it do? Is it sharing mesh data here? Like if I go in here and I move this, okay, so it is still correctly sharing the mesh data, which is good. The materials seem to, oh wait, sorry, this is, I'm a dumbass. I imported our GLTF, not the GLTF that Blender exported. Hold on, import GLTF, let's try again. So he exported this thing, so this is blue and red, and these are now referencing different meshes, which kind of sucks. That kind of sucks. I was kind of hoping that we could like trick this thing into using the same mesh over and over again. And it looks like it's not doing that. And that's really just because like these guys are using different materials. Ugh. So are you really telling me that like in Blender or like in GLTF format, there's no way to like instance objects, like instance meshes with different materials? At least like the on disk format doesn't make us re-instance it over and over again, but I bet that means that if we are going to like export thousands of cones into this thing, Blender will then have to render each of them individually, which could really like choke it up, which kind of sucks. GLTF. Let's make a new format then. Yeah, one more level, baby. I mean, at that point, I think it's better to just write a 3D renderer, but I wonder if it's possible. GLTF instance share mesh different materials. Okay. Searching for the same geometry. So in 3GS, they're just like, is it the fucking same? Which is kind of funny. Why is this like closed? I don't think any change is needed here. This hasn't seemed to be an issue in practice. Why? How come? When the same geometry is present in the scene associated with multiple materials, the mesh itself cannot be reused. In that case, I would expect authoring tools to write multiple meshes with primitives referencing the same accessors. In 3GS, where two primitives contain the same accessors, we optimize by using the same geometry. And Blender is just not doing that. Okay. I mean, maybe it's fine. Have you looked at USD instead of GLTF? Dude, I like just typed GLTF in. This started because like an hour and a half ago, I was like, can we instance obj files? And he said use GLTF, and that's about as far as we've looked. But okay, this is a limitation. It looks like people don't really care, so maybe it's fine, and maybe we just try it and see what happens. USD might be interesting too. It's a Pixar's open format. Yeah, I've definitely heard the name. I've heard it's good. The fact that these meshes are using the same thing means that like I wonder if Blender over time would like figure it out. Like if if it's scaled up enough, if he would get pissed off or something. Can we also like maybe close Blender and fully restart it? I wonder if it has something to do with the fact that the name was already taken. That's like a very real possibility. So I'd be curious to see if we re-import here now. We have our two triangles. And are they referencing the same mesh? No, they're not. Okay. It's fine. I would assume... Oh, wait. I wonder... Maybe there's like an import option as well. We could look at that as well. It wouldn't shock me if it's like, oh, you know, you probably don't... You might not want to do this, but you might. Right? So can we like merge vertices... Guess original bind pose, lighting mode, bones. Yeah, okay. Nothing in here is really saying like try to deduplicate meshes. But maybe it's fine. Can you load 1,000 triangles now? Yeah, I guess we might as well just fucking try it, right? We might as well just try it. So let's make it so that we have maybe each of these things are gonna have a color. And that means that each of these guys, instead of making many nodes, each node has to reference its own mesh. right? So here we need to keep track of the index, like this. This is going to take mesh index now, and we're going to have to then also make our meshes. So actually, let's just ditch the colors thing first. We'll come back to that. And our meshes now needs to be editable as well. Okay. So this is going to be a GLTF mesh, which doesn't exist yet probably. But we'll just kind of whoop, yoinkies. Okay, so this guy comes out like this, and we have GLTF mesh here now. Womp womp. And where does the material slot go in here? In the GLTF spec? Oh, fuck. Should we, here. It was, meshes. I lost out here. So it was material next to attributes. Okay. Right? Yeah, okay. So, out mesh, I guess we'll call this. And here we'll say out mesh equals name. I guess we don't care about name. We do care about primitives. Wait, hold on. Why are there many primitives in a mesh? Oh, I see, because a mesh could be built up of like many disjoint segments. Okay, sure. But our primitives are always going to have one thing in them, and it's going to be attributes. It's like this. Normal or something? Have I fucked this up big time? Can we just actually do this? Out mesh equals this. Okay. Copy paste this guy. And go back by one. Okay. And it's position 0. Everything references the same mesh, but now he has material. And this is going to be index here. But for now, we're actually just going to we're not doing the material stuff yet. We will get there. Okay. So now meshes down here needs to come from meshes. Okay. Which compiles. He's mad because what? We probably double freed this because I didn't change this to say meshes here. Whoops. Okay, and so now we should, when we import to Blender, we should see two triangles with disjoint meshes, I think. Are we exporting or importing here? Which one did I click? Import. Work, code map, here we go. Okay, so we get our two triangles with two individual meshes. Okay, which is a little lame, but we'll be fine. So now, can we just see what happens if we instantiate these things like 5,000 times? So we're going to say like positions is going to be maybe like 1,000 vec3s. Okay. Here we take the positions and we use them here. And can we just go like, maybe we like randomly instantiate them? So we say like for 0, I guess for like positions, we do like pause 0 is equal to RNG, like, what is it? It's like random float or something. PRNG is stood random default PRNG initialized with 0. We get the like random is the random interface out of this thing, and then we say like random dot float. F32. Pause 0 is equal to this, 1 and 2. Maybe the third, the z value, or they have y, it's y up, right? So maybe the y value is going to always be 0. We'll kind of make like a field of triangles. Okay? So let's look at the GLTF here. And we do see just like a million of these guys. Nice, each with individual meshes. Okay, and if we import this thing now, import this thing, it looks fine. I'm not like choking. I'm not choking too hard, which is good. I guess these are all in the range, -1 to 1. If I look at like this guy, can I look at his translation? Yes, he's like -1. Yeah, okay. I mean, it's not fast, but it's like fine. Looks like we will live. I probably shouldn't have closed Blender there. Okay, so now can we add like colors to all these guys? So can we go like positions, colors? And can we just do the same thing? Let's give them each a random color. Okay, and then here we'll pass in colors here to export GLTF. So now we need to say that we want colors in some way. Any reason you're not using an arena? For what? For which part? Okay, so then we need to specify materials here. So each color gets put into his own material. So here we need a GLTF material that comes from instances len, and probably we just like std debug assert that like instances len is equal to colors.len. Doesn't really fucking matter right now. Okay, now we need to like make a material, which I think we haven't done yet. Materials, materials, materials. Nope. Okay, so what goes in like a GLTF material? Do they all use the same PBR? Can I just like give them like a dumb shit? GLTF uses the metallic roughness material model. Okay, sure. So I guess everything is like this. So PBR metallic roughness, and I must are like these required? I think we'll assume that they are for now. And this is a vec4. That's mesh, not material. God damn it. Thank you. Good eye, good eye, good eye. PBR metallic roughness. Okay, and it was these. Okay. So I guess it's like 4 F32s. This is an F32, and this is an F32. All right. So now we're gonna make a bunch of GLTF materials, which means that here we're gonna have materials as well, probably. Material. Probably it's better to do separate loops here, but fuck it. Right? This is like, you know, we're referencing like many points in memory at each iteration of the loop instead of one, which means that the prefetching is probably going to be harder, but, you know, you can suck it. It'll be fine. And so here, we also, actually, you know what, fine, we'll do it right. We'll do it right. So the mesh needs a material index, which we have, which means that here we can just say that the mesh has a material is equal to index. And then we'll go over the materials separately. So we'll say for colors materials, color out material. We say out material. I think in this case you could have a single arena for the whole program and not worry about freeing. No, I mean at that point, well, we could just not free at all, right? One arena for the whole program is the same as a general purpose allocator that you don't let go of, right? I'm doing it this way because I just want to check that I'm doing I just want to make sure that I'm doing it right. I guess for if I factor stuff out later and copy paste that type of shit. Okay, so our material, each one of these guys is going to have a PBR metallic roughness. And we have base color factor is going to be color 0, color 1, color 2, and 1.0. We're going to say full alpha all the time. Metallic factor, probably 0. And what was the other one? Roughness factor, probably 1. We probably want this thing to be rough and non-metallic. I think that will look the best. We could also do shiny, but I think this will look most like just solid color. Okay. So then we just set the materials to be these things, which means we should be able to be like materials here is an optional list of GLTF material. And then down here we just write like materials equal materials question mark. And then hopefully we import this stuff into Blender and we see a different color per triangle. Import GLTF from work code map test GLTF. Okay, and I hope that my computer doesn't blow up if I click this button. Okay. Oh, that's kind of fun. They have like a orientation, I guess, and all of these guys are white, which kind of indicates that the material isn't getting properly set. It does look like we have individual materials here. Material 999. I think we fucked this up. Somehow. I don't really understand how, though, because our materials here are supposed to be incrementing. Can we look at test GLTF and see what the fuck we've done here? Material. So these do all say 999, which seems bad. I mean, he's definitely doing, like, they're doing what we asked of them, so... The fuck? Hello? How are these all getting 999 if the meshes are not incrementing, right? We're seeing mesh incrementing correctly. Material fucking stuck. So, like, what have we done wrong there? What have we done wrong? Material, index, mesh, index. They're using the same fucking number. Right? Oh, is it like this slice? Surely not, right? Is it that this address of temporary is a location on the stack, and that location of the stack is getting overwritten every time? I wonder if we say 1 here instead of what we're doing there, where we say, look, we're not going to support multiple primitives here. That way we can do this in line without any issues. I wonder if that will do something different. Yeah, okay. So that's just like, that's what happens, sure. Sure. Okay. So now we should be able to import this thing, and everything should get its own material now. Uh-oh. Okay, my mouse is still moving. We're good. And hell yeah, there are our triangles with different colors. Look at that, baby. Look at that. Look at that. Oh, that's pretty sick. Pretty sick. All right. All right. So now the question is what's next? I guess we could try to use this in order to visualize a voronoi. We could try to actually export voronoi diagram. Okay. So I guess we need to adjust this to take in a cone. Okay. So hold on, let me think for a second. Let's start by making an arbitrary voronoi diagram and showing it in OpenGL. I think that will be useful. That'll be like the easy way to test this. So we'll go here and we'll copy our existing visualizer, and we'll just change this to like a I don't know, like voronoi viz zig or something, and we'll just delete anything in here that isn't related to making voronois. So kind of delete all of this, okay? And then can we actually, instead of using like real data, I wonder if we can get away with like just creating stuff on the fly. So let's kind of delete all of that stuff, delete all of this stuff, delete. We don't need any of this shit. We probably don't need the vast majority of this shit. I'm just trying to get like something that like makes a window. Delete. Most of this stuff is all. Oh wait, this is the windowing stuff. We need the windowing stuff. Okay. I think this is about right. So let's just kind of render a voronoi here. And we just have to initialize our voronoi buff with some stuff. So let's start by just making one thing here. We'll make one cone in a voronoi diagram. Very simple. Offset 0, 0. Color red. Distance threshold 2.0. Okay. So if we do this and we run it, we should get one circle somewhere on our screen if we did this right. We need to add this to our build.sig. What's the most convenient way to view a GLTF on Linux? I mean, I use Blender, but I'm sure to each their own. So this is voronoi test, I think we called it. And then we probably need to link GL and GLW. Like this, and then we need to install this guy. All right. Let's see what happens if we run that. Fuck. What did we call it? Voronoi viz.sig. Fine. Fine, if you're gonna be like that. Fuck. Sure. We probably can delete. I guess he needs to add some imports like that. How did Viz do this? Oh, we did this. Boom. Okay. Voronoi test. Add this shit, please. Maybe? Okay. Zig out bin voronoi test. Okay, so we have one red thing. His threshold was very high, so he's filling the whole screen, which makes sense. But if we add in a second guy here with an offset, offset, blue guy with offset like negative 0.5, negative 0.5, we should start to see, oopsies. We should start to see like some, yeah, here we go, a little line here indicating, oops, why are we out of memory? Because we need to clear our GLW input buffer, probably. Probably something like this. That was kind of scary. I'm surprised that it like kind of went so well. I would like to actually top this thing and make sure that we're not like memory leaking anywhere obvious. Seems fine. Okay, cool. So let's try to randomly initialize this voronoi diagram in the same way that we were in the other thing, right? So we say like, let's go over here to, what was it? GLTF test. In here we have some RNG that we initialize things in. So we'll kind of do the same thing here. We have positions allocated the same way. Maybe we have like 1,000 positions. Maybe that's too many. Let's do maybe like, 100 or something for now. And I guess the position, these are actually going to go directly into like the voronoi data, which means that we probably need to take a slice of these voronoi instance datas. So this is actually going to be voronoi data is going to come from node voronoi instance data here. Okay, so we're going to make 100 things. 100 things. And for each of these voronoi datas, we edit them. And I guess we say like D offset 0, random float 32, same with offset 1, and then we do color as well. Okay, and then we also have D disk threshold. We'll just set this to 2.0 kind of unconditionally. And then we use that in here. And we should see something that's like pretty. Pointless discard of allocator, not reusing it. True. Okay, here we go. We're going from -1 or 0 to 1, so we need to adjust the positions a little bit. So we go like this, multiply by 2 minus 1. There we go. There's our voronoi. Okay, so now what we want to do is we want to merge these two things together so that we can export the GLTF of this same voronoi that we're visualizing here. So I guess we take the test GLTF bin. Oopsies. GLTF test zig maybe? Yeah, nice. We take this export function. We just take all of this shit and we copy paste it into here. Maybe cut and paste would be better because I don't want to accidentally modify the wrong one. But we are making our bed and we will sleep in it later. Okay, so now all you have to do is export GLTF here. And I wonder if it makes... We have, okay, our mesh is owned in here. Somewhere in our voronoi data, we make these cones. We must. We have gen cone. And it looks like we kind of insta-delete it. So the cone data like lives on the GPU, and then we lose it, which kind of sucks. Maybe it makes sense here to do like gen cone vertices that returns num cone points of smath vec3s, okay? And then we can kind of do this part here. We can go like cone points is equal to gen cone vertices, like this, and then we can kind of call this externally. Which makes sense. Sorry, I asked that question and then immediately went to get food. Was kind of asking myself, classic, thinking out loud in Twitch chat. Okay, so now we should be able to like create our mesh here. We should be able to be like no voronoi gen cone vertices. We have like our cone mesh here. We should be able to like export GLTF allocator with our mesh. Now we have our cone mesh. Hell yeah. But we need to. These things are like padded, right? We already found that, so we have to go like cone mesh packed. It's gonna be I don't know. Alec for now. I don't really give a shit. Of like cone mesh 3 times this length of floating point 32s, and we go like 4 cone mesh. For 0 to cone mesh len, we have some index, and we populate the packed version. So we say like cone mesh packed I times 3 equals cone mesh I0, and we increment y1 and 2 here. Ugh. We're going real ugly code mode right now. I really don't give a fuck, dude. And can we export a GLTF with this thing? However, yeah, let's just start by export GLTF with our allocator, our cone mesh. And then we need to specify what? It was instances and colors. We're going to have one instance at 0, 0, 0 with one color of, it's like this, I think. With one color of red. Okay. What else does this thing want? He wants like the GLTF path and the bin path. So we can just say like test GLTF and test GLTF bin again. Okay. What's he pissed off about now? Expected semicolon after what? What's he pissed about? Oh, I've got extra curly brace somewhere? Why? That seems fine. What's he pissed about? Oh, maybe dot here? There we go. Array literal. Oh, we need to coerce this thing into the cone mesh. Okay. And then he thinks that. Oh, packed. And then this is not ampersanded anymore. Okay. So now if we run this voronoi test, we get our voronoi thing, and we should also, as a side effect, export this GLTF that we can pull in here. Like, can we delete everything? Import GLTF of test GLTF, and we should get a cone here, which looks like fucked. That's kind of interesting. Because we export the cone is a triangle fan, and GLTF needs us to be individual triangles. Sure. So we actually need to go. We actually need to do. This is like, fuck. This is like -1 times 3, I think. Because what we have is we have defined the points of our cone in like this order: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or something, right? So this is 1. So this is, how many triangles is this? If we have, okay, let's do less points. So we have 0, 1, 2, 3, right? This is a cone. The cone will look like a pyramid, but it's a cone. So this is 1 triangle, 2 triangles, 3 triangles, for 4 points. Yeah, so we subtract 1 and times 3. And then as we iterate over each triangle index now, so I guess we'll say like num cone triangles is equal to this. Again, we are really just like fully embracing shit code prototype mode. Okay? We are fully embracing it. Okay, so we index from the first point to the triangle will always be the top of the cone, which is the first index. So we should be like cone mesh 0. Then we iterate, the other 2 points are like the index. Hold on. So we need to do this in sets of 3 because points are in 3D. So it's kind of like this. Okay. So this is vert 1. We get this stuff. So I think that we're doing 3 vertices per triangle here. So this needs to be times 9. I think. Right? Because num cone triangles is this, which means we need 3 of each, 3 points for each triangle here. Yes. Okay, sure. Then the second point is going to be the second triangle here comes from cone mesh I plus 1. Probably. I'm really just guessing here, but that feels kind of right. 6, 7, 8. And then that hand wavy feels like it could be right to me. I'm at like maybe like 30% index out of bounds. So there's probably like a wrap that we have to do here. Unless the wrap is kind of encoded in this thing. It looks like the points include the wrapping triangle. Okay. So where am I going out of bounds? Cone mesh on I plus 2. I wonder if we have to do something like this. No. What am I missing here? Let's draw it. So this is 0, 1, 2, 3, right? So if we are going triangle by triangle. We have triangle 0, 1, and 2, right? So for triangle 0, we're looking at 0, 1, 2. And then we have to keep in mind that this is also 4. Ah, so the last vertex is doubled, which means that this needs to be minus 2. Okay. So then we go, for triangle 0, we look at 1, 2. Or for, I guess it's like, yeah, 1, 2. Then for triangle 1, we look at 2, 3. For triangle 2, we look at 3, 4. Okay. So triangle 0, we look at 1, 2. Triangle 2, we look at 2, 3. Okay, so that seems fine to me. Although he's still happy, or still unhappy. If we do a -1 here, just to try something. Okay, interesting. And we're actually, it's on the cone mesh packed side where he's pissed. Because this has to be times 9. No. I'm doing something stupid here. Why is it times 9 here, but times 3 here? I think it has to be times 9 on both. Okay, so now it's at the cone mesh thing. He doesn't like cone mesh I plus 2. What I thought it would be fine because we have cone mesh len minus 2 here. Why does it say times 3? There we go. Okay, that seems a little more reasonable. And can we look at what we exported now? Not quite, huh? Not quite. Can we disable backface culling? Zero, 1, 2. Oh, 3, 4, 5. We have the indices wrong. Okay, let's try that again. Okay, we want one more time. Okay, there's our cone. We do need to disable backface culling, which is fucking annoying. Backface cull, double-sided here. So this is part of who? Material? Yeah, it's part of the material. Okay. Double-sided bool equals true by default. Does that fix our problems? Import GLTF, GLTF. There we go. Nice. There's our cone, baby. There's our fucking cone. Okay, so now we should be able to visualize this exact same voronoi in Blender if we get tricky with it. So we should be able to say, hit me with all of these guys. And our export GLTF has to come after we generate our random data, right? And I guess what we'll do is we will say, I guess we can generate the mesh up here still. It doesn't matter, it's fine. It's fine. Okay, so here we're gonna go for voronoi data. We're also gonna go for export colors is going to be, what was it? It was like vec3s of voronoi data len, okay? And then we have export positions as well, which was vec3s as well. And then we just set these at the same time. Oopsies. So here we just say like export positions 0 is equal to d offset 0. And by export positions, I mean export position. Okay. 1, 1. And 2 is presumably just 0 here. Except I think that we need to invert these. I think that we want these to be on y is up. So we want these to be kind of along the xy, the horizontal plane, I think. Then we also track the export colors here. And here we just do the same thing where we say like export color equal D color or something. This is this is, these are the same. Wait, what's this about? Oh, because D is a pointer. Okay, so now if we export these things with export positions and export colors, okay, we should be able to open up this thing we just made in Blender and see the same shit. We're so close, except the cones are rotated the wrong way. So we actually, we're just gonna use like the different plane. So that like XY flip I did before, we'll just undo that. And I think we should see the same shit. I accidentally closed Blender again, I keep doing that. Import GLTF. We look at work, code map, test GLTF. And this should be like the same fucking thing. It's kind of hard to, maybe we'll screenshot this so that we can get it smaller. Close. Right, like this guy, fuck. We'll do like an always on top here. These should be the same, right? You can kind of see like there's some inversion of, there's some like upside downness here. This is like mirrored over the y-axis, I think. Right, this blob here is this one right here. Are these guys not, can I not like select? Oh, I see, because the fucking cone goes outside. Right, so this is this is this is this, right? So now we have like a 3D representation that we can like look at that is exactly the same as the voronoi diagram we're generating, which is pretty sick. This is going to make it way easier for us to like do some debugging later. That's pretty hype. That's pretty hype. Look at that shit. Here's like this little cluster down here. Look at that. Isn't that awesome? Look. Oopsies. Look at that. This is this. Wow. Isn't that sick? It's pretty fucking cool. So I would say that's a success. We have managed to export our voronoi diagrams into Blender using GLTF. We've kind of raw dogged the GLTF file format, but it really wasn't that bad, right? There was nothing in there that was too crazy. The like idea of like meshes are defined. We have like binary data, arbitrary binary data, and you can define like custom views into that binary data to associate with accessors, which attach like typing information to the binary data. Then you attach the mesh. You say, hey mesh, look at this accessor. This is where your data comes from, and you create materials that maybe I wonder if the colors could also come from the binary data. How did we define materials again? I forgot. How did we define materials? The material has a inline JSON representation, right? So we have to say, hey, this is like these are our physically based rendering properties associated with that thing. This is kind of nice. If we were gonna do this this same render with our own OpenGL 3D engine, we would have to implement like in order to give like definition to 3D objects, you need to define some sort of lighting. So we would have to have added normal light calculation to our OpenGL shader, which would have been like maybe a little bit annoying, probably less annoying than this, but still. Why do centroids of some cells not be where they should? It could be like orthographic projection, right? So if I look at this thing like this way, I think it's pretty much the same. I lost the screenshot, but I'm pretty sure it's right. I'm pretty sure it's right. Yeah, so the materials are defined inline. What else did we learn? Then yeah, you have nodes, and then we didn't touch scenes and stuff, but you could define scenes. Pretty sick. Pretty happy with that. I think that like the one I do wish that we could have instantiated all of these nodes with the same shared mesh. It kind of sucks that Blender doesn't try to deduplicate these because they are all accessing the same mesh data. But you know, it's fine. Cool. Yeah, I think that's fine. Thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 2:50 now, which is kind of odd. We were planning on doing like a happy hour stream of this today, followed up with something else later. But this turned out to be like interesting enough that it deserved its own stream. So today's a little bit of an odd day, but typically 12:30 to 4, 12:30 to 2 is happy hour, 2 to 4 is the main stream. What you're seeing is the main stream. Happy hour is kind of like side quests, cleanup, refactors, small tasks that don't deserve their own video. If you're watching live and you want to keep up, there is a YouTube link in the Twitch description. VODs are here, organized into playlists. We're working on this code map. We've been doing lots of side quests in this thing because it's kind of fun. But this is kind of like the overall project we're working on. Eventually, we'll get back onto our image editor. Code for this should end up on GitHub in some way, shape, or form eventually. I don't really know what that will look like. If you're watching on YouTube, you will notice that we're only shipping the main stream as VODs here. If you want to watch the happy hour segments, which are a little bit more chill, a little less focused, a little more kind of like whatever, you hit the join button here. You can sub on Patreon, you can sub on Twitch to get VOD access, or you can catch it live at 12:30 Pacific time. I think that's it. Tomorrow we'll be back to do some performance improvements of our voronoi building. And I will see you guys tomorrow. YouTube, peace out. Twitch, let's find someone to raid.